All right, it's looking like we have a good group here to get started. We have some introductory remarks, so I'm sure additional people will join. But my name is Yvette Seeger, and it is my pleasure to welcome you to today's DataWorks Salon on selecting a data repository. At FASEB, I am the Director of Science Policy, and I work with the DataWorks team to offer the variety of products through the DataWorks initiative. Today's speaker are frequent flyers, as I like to call them, for the Salon series. They have been really engaged in the chat of previous salons as well as moderators. So really excited to have them today. We have Sun Young Kim, a senior support scientist at Washington University School of Medicine in St. Louis, and Nina Eckner, a research data librarian at Virginia Commonwealth University. And our topic today is selecting a data repository. This is, part of everyone's plans for data management and sharing. And we know it's a hot topic for all of you as you're getting ready to plan your data management plans. And I will turn it over to Nina.
Thank you so much. Can you hear me okay? All right. Thanks for the thumbs up. So I'm going to give the overview and background. Some of this may repeat things that you've already heard in other discussions of the NIH DMSP policy, but it's always important to situate that repository selection isn't an isolated thing by itself. There are certainly best practices and what's a good repository and a less good repository, but when we're thinking about funded research, we really want to make sure that we're also compliant with the regulations and guidelines. And a lot of those are really contextual to the specific funding agency. So why are the funding agencies asking for us to share data? Well, there's a lot of reasons, and you may have seen things related to them also in other major societies like FASEB, but the federal policy level, trying to improve the research enterprise across the nation, wants to accelerate discovery by using more modern and technologically engaged interfaces, supporting reproducibility and transparency, which really kind of spreads throughout the entire principle of sharing data. And that especially feeds into building trust in research and science. There's also the interest in enabling future integrative science, the ability for AI or future models that we haven't even imagined that may need long years worth of trends of data to be able to have that data invested in. You can't say today that we want data from 1950 to have been shared. So we really want to make sure we're sharing now for the future. Ultimately, the tax-paying public and citizen scientists are a lot of where the support for the funding agencies come. Funding agencies do not work in a vacuum. The taxpayer and the general public are an important part of the scientific communication cycle. And that means that we want to enable people to, in the tax-paying public, to reuse our results and maximize the impact of them. And also, considerable amounts of evidence have shown that sharing data increases the readership, the citations, even the speed through peer review of articles associated with that data. And so there's a lot of interest in expanding those benefits. What's new-ish about the idea of sharing data, especially sharing smaller individual sole PI or small team research, is putting it in repositories. And you will hear throughout this session that a repository is not just whatever we call a repository. It's not our fridge that's in our freezer that's in the next office over. It's not our departmental file server. It's not just whatever our campus decides to call a repository. And that's because data preservation is really not our specialty as scientists. It's the specialty of people who work in archival preservation, and leaving preservation to scientists who are concentrating on science has generally left data preservation to languish a bit because it's not the priority of the bench or field researcher. So an approved data repository, and Seonyang is going to say a lot more about this. Dr. Kim has the majority of this time around this, but an approved data repository, there's a whole set of guidelines around what makes an acceptable data repository for the hosting data sets resulting from federally funded research. It needs to have a persistent identifier to help future citations, your citations of data. It needs to be an archival digital preservation system, not just a technological storage system. And it needs metadata and other structures that help future scientists to locate and retrieve the data that you share. You may be saying, what is a PID? What is a persistent identifier? A website is an identifier of some sort, right? There are a lot of different PIDs. These PIDs are very important for being able to follow files that are shared online. Without something like a PID, as soon as a campus migrates they rename the campus or they change their web servers, those files that were up there in a departmental preservation or a lab preservation website are going to disappear. So good preservation needs some kind of identifier. Most commonly, we think of a DOI, but there are a lot of others, some called handles or arcs or pearls. Even a PMC ID is a kind of a PID. And we won't talk about it much, but you could attach data to a public access article filed in PubMed Central. For those of you that work with multiple federal funders in the US, it's worth warning you that the NIH new-ish last year started DMSP policy is only an example. Well, the DMSP requires that you submit a data management and sharing plan and then update it as a program staff requires during just in time, and then actually comply with it by closeout. And they've been pretty firm that they're going to really check those. All federal funding agencies are currently working on and will be required to issue similar guidelines about data sharing by the end of this year, and those will come into effect the end of next year. So if you do nutrition research and you get some of your funding from USDA and some of it from the NIH, USDA will have new rules. Everyone is required to have these rules under US federal system-wide rules. So the NIH DMSP is an example, but it's only one example. That NIH DMSP, or Data Management and Sharing Policy, has 6 elements. You've almost certainly already seen this, but just in case you haven't, or just working towards your first proposal since it came into effect this time, those 6 sections are data type, tools, software, and code, standards, data preservation, access, and associated timelines. And that 4th one is a wordy way of saying, what will you share and when will you share it? Or how will you share and when will you share it, I mean. Access and reuse considerations, which is a fancy way of saying reasons to limit sharing. And then oversight of that sharing. I won't go through all of those, but 2 that are especially relevant to the repository selection process are element 1, the data type and documentation, which has 3 subsections: the types of data to be generated, and then separately the type of data to be preserved and shared. So you generate a lot of data and they want you to summarize what all the data you will generate is, but you may not share all of it. You may share it in a certain format that's not the generated format. So maybe you're going to share summary data or cleaned data, partially de-identified or fully de-identified data. So Section 1A is all of the data summarized. Section 1B is which of that will be shared in the repository. And then Section C is documentation to be shared alongside that data so that it's not just a spreadsheet of, Western blot result 1, Western blot result 2, Western blot result 3. We really need to have more than that. And so what documents will go alongside that shared data is an important type of this data type and documentation. The data type relates to my arrows didn't go through here. I'm having a lot of tech problems today, sorry. The data type and repository kind of feed on each other, so they go back and forth. That was supposed to be a left and right arrow. Because you want to think through whether your data type, and in that I kind of mean like the file type you save it as. Is it a spreadsheet? Is it a Stata file? Is it a complicated MATLAB or hand-coded model or simulation even? Are there images with it? Are there gazillions of images with it? Different issues about what technology you use to save it, what kinds of file, what the file extension is, what software you open it with, is going to affect where you can store it. So that's something you need to consider, like what does the save as and what type of file it is at the end. That's something you want to consider in choosing your repository. Especially as an added twist, if it's going to be very heterogeneous. So if you're going to have images and quantifications and models and, that's going to be a very different process of putting it in a repository, or in the case of heterogeneous data collections, maybe multiple repositories even, than if you just have one spreadsheet that's all of the surgical outcomes of these mice. They're going to be very different situations, very different saving and repositing and sharing processes, and also documenting processes. If you're not really sure, you might think about if there were another researcher and you read their article and you really wanted to incorporate and build on their article and it's similar to yours, like how would that look? Or imagine when you were a postdoc, or if you are a postdoc, think about how you would pass something in your lab to the next postdoc and what you would want to see in that to make it really kind of able to be built on, and what file formats you would want to have in there or expect to run across as you go through that data and try to make sense of it. I've said that that data type section has what's to be generated and then what's to be shared. Not all of the data has to be shared. Element 5 is access and distribution considerations, or things to consider in what can be distributed. You can describe ethical, legal, or technological considerations to justify non-sharing of your data, or limitations to that sharing if you're only going to share part of it. So not just any reasons, but ethical, legal, or technological. You need to describe those considerations fairly specifically. One of the first feedbacks we've gotten this year of what NIH staff have disliked about what they've seen over the last year has been that a common shortcoming is people are just saying a really general reason. Data will not be shared for ethical reasons. That's not enough detail by itself. So we do need to say something more deep than just because of ethics or because there might be IP. There needs to be some detail. We're including a checklist here with the slides which will be distributed to everyone after this. I'll also pop a copy into the chat after I finish. Some of the reasons that have been listed as justifiable and some reasons that are specifically not listed as justifiable. Some much more niche considerations like inventions and policies or SBIRs, STTRs, and then sort of tech transfer arrangements. And also remember that tribal sovereignty arrangements always trump, and in fact, any legal arrangements always take priority over sharing. And so tribal sovereignty is definitely a reason to limit sharing by a non-tribal investigator. If you're not sure if you can write up a robust ethical or technological or legal reason, but you're still not comfortable with open sharing, maybe because you can de-identify, but you still feel like it's a risky topic, you could consider a restricted access repository. Some repositories, as you select your repositories, have the option of having release only under certain circumstances. And that would be something to think about as you're considering selecting your repository. And with that, I'm going to transition over to Sun-Young Kim, who will talk more deeply about the whole repository selection process. Thank you.
Sorry about that. Technical problem. Should
No
I swap?
problem. Yes, swap presenter mode, but I'll take the opportunity to thank Nina and then just remind our audience, feel free to ask any questions you have in the chat. We'll also have Q&A at the end of the presentation because it's meant to be a discussion. So now your slides look perfect.
All right, thank you. I added this slide not to talk about everything I did in the past, but as a way to show, use me as an example. There's no set path to become a data librarian. So I've done a lot of different things, but all this combined experience as a researcher generating, managing the data, but also dealing with the regulatory and compliance in the industry, even in IT, helped me do my job as a data librarian. So I want to encourage you to consider doing librarian job or moving into that direction because we need more of you. So that's the only reason. Now, moving on to sharing. So these are the things to consider for data sharing. Sorry, I have a little problem with the throat. The one thing I would say is plan early. The reason NIH places them as policy is to help researchers go through the mental exercise of managing and sharing data before you even start your project. I'm sure many of you have seen those snafu video by Langone Library. It's a horror story when you did not manage your data. Data gets disappeared. You don't know how to track those things. So plan early from the beginning. And one thing you can do has a README file in each data folder to collect all necessary metadata information, which you will need when you share the data in a repository later. And there's a great README template. If you're interested, I'd be happy to share with you. And then do that as you collect, analyze the data, because later on people leave and you might not remember accurately. And data sharing is about showing your work. So all data, even negative or null results, have potential value. How many times you have a data set you don't know how to interpret, but then later on you put the pieces together with another piece, then you end up solving the problem. So I view science as a huge puzzle. We all generate a little piece to tackle, kind of solve the big puzzle. So all data has a potential value, so save them and share them so that we can further our research future. And Nina talked about, justify reasons for sharing, for limiting sharing of your data. Even so, you should be prepared to share enough information about your work so that others can evaluate and potentially replicate and make use of what you've done to accelerate future research and direction. And the last bullet point is the most important one. The data sharing is about make your data fair. I'm sure you heard about it. Fair means findable, accessible, interoperable, and reusable. I talk about more in detail. I put a link in there. It's my 4-part blog series about fair data principles. Feel free to check it out. So I can go over the details, but in a nutshell, to make your data findable, accessible, interoperable, reusable is having a PIDs, Nina talked about. So, it makes your data set findable and also accessible. And interoperability is about using the common data elements like a community-wide accepted standards and ontology so that when you move data from one situation to the other, they can be interoperable and then convert it to open file format. So you don't need a special software to access and analyze your data. And the last point about reusable is very important because if you don't specify your data is available under what license, you might as well get lost because data that is legally encumbered, ambiguous or unknown access and archiving rights may be considered lost because the cost of clarifying the rights situation is very prohibitive. So you need to make sure your data is available under what condition is a completely open access or under data user agreement, restricted access kind of thing. So that's a very important one. Sorry. So I'm going to talk a little more about persistent unique identifiers. It's increasingly important, especially after OSTP Nelson memo about public access policy and NSPM 33 memo emphasize the use of PIDs. So yesterday, actually, there was another report released by ORF PID Strategy Working Group, and it's about strategy of using, PID, and it has a recommended common PIDs. Researchers need to use, and these are some examples of PIDs. There's a PIDs for people, ORCID IDs, everyone knows about it, and it's required for all the federally funded research and in publications as well. And PIDs for places like research organizations, ROR, funder ID, and grant ID. And then PIDs for subjects, DOI was mentioned, is probably most common PID for research outputs like publications and even protocols and data sets and code and stuff like that. And one thing I want to emphasize the RRIDs. These are research identifiers. So it's a PID for like antibodies or plasmids or even software databases, and these are very important for rigor and reproducibility. So I encourage people to use that. And the new one, which at a higher level called the RAISE, Research Activity Identifier, was actually in the list of recommended PIDs in that newly released U.S. National PID Strategy. And this one, when you have a lot of research outputs, you kind of combine all together. So you can put all the research outputs and the ROR and DOI all in one ID. So it helps you connect all together and then make it machine actionable. And DMP IDs is a ID for data management sharing plan. If you write a DMP using a DMP tool, you can assign a DMP ID. And this is another important one. It was incorporated metadata schema 4.4 and up. And if NIH wants to kind of, check the compliance issue, and they can quickly see what research outputs were generated from funded DMSP, and it'll help in the data citation corpus in the future. So I think this will become an important PID moving forward. So now with that, let's talk about how to select a repository. The short version is, if your program indicates a mandatory repository, deposit there. And if you don't have that, then you go to the domain specific or data type specific repositories. If you find one, deposit it there. If you don't find a domain specific or data specific repository, then you choose an established generalist repository that meets the desirable characteristics of data repositories for federally funded research recommended by NSTC. Now, I talked about it's not, just a regular repository. It has very specific requirements. So there's a generalist repository, and institutional repository is also generalist repository offered by institutions, but not all institutions offer that. So we'll talk more about it. So now move on to these desirable characteristics for data repositories. So must have a persistent unique identifiers, has a plan for long-term sustainability, must have rich metadata, because that's what helps people understand how the data were collected, analyzed, and then reused. And then creation and quality assurance has to be in place, and then offer free and easy access, and broad and measured reuse, and clear user guidance, license, either Creative Commons or restrict access with data user agreement kind of thing, and security and integrity in place, and measure for confidentiality, and convert to common format like open file format, and should have a provenance where the data was originated, and kind of thing, and the retention policy, and it has to be placed in the plan in place when there's a disaster occurs and stuff like that. So those are things that are all important and must be in place to be qualified as a data repository for federally funded research. And there's additional characteristics for human data as well. So this is a common mistake. A lot of times researchers think, hey, I can use data storage form, Box, Dropbox, Google Drive, OneDrive, RedCap, Lab Archives, and blah, blah, blah. Those places, those platforms do not meet the desirable characteristics, and personal website definitely not, lab website definitely not, or repository you built on your own if you have the skill set, but it's not going to have all the characteristics in place. And available upon request is definitely not. And you will see, yeah, definitely not, exactly. So, in the past, I think a lot of publishers would allow that as a data availability statement, but they're moving toward requesting a DOI for data sets. So even before they start reviewing manuscript, you must have your data available in a repository and provide a DOI. So it's, and then as Nelson memo kicks in, public, policy becomes effective, it's going to be more and more request for PID for your data set. You have to make it available. PI cannot be a gatekeeper for the data set. So let's talk about decision tree, how to select a repository. As I mentioned in the short 3 steps, first step is look at the funding opportunity announcement or notice of a funding opportunity no-fall. So if I gave one example here, so this, if you review the FOA, there's a data management sharing section. If it calls for specific repositories, such as in this case, NI's Elite Portal, then you have no option, you have no choice. You have to deposit all your data there. So if it's not listed, then you go to the next step, and then you look for model organism specific repository. And if it exists, if you're working on mice or zebrafish or C. elegans or Drosophila, these are the model organism specific repository. They want you to deposit your data there because it's designed for that specific data type. So if you don't find it, then you go to the next step and look for the data type specific or method specific repository that can be used. And this is most list of repository you will run into. So there are many different data types. This is where the data types comes in. So there's the imaging data, biochemical, biophysical data, omics data. Omics data can be genomics or proteomics and metabolomics. So I give you a list of data repositories under each category. And if you're working with the qualitative data, there are specific repositories, for those type of data, such as ICPSR, QDR, and DataBury. But it's a huge list. So, where do I find those things? So I'm going to talk about resources for finding those repositories in the next slides. And if you don't find a data specific repository, then you look into generalist repository or institutional repository. But I'm going to add one more category here. So a lot of times, NIH-IC will have IC-specific central repository, which kind of almost like a generalist repository, because they can accept various types of data type. But it's very IC-specific. So I'll give you an example, like a NIAID import, great repository. They accept pretty much every data type you can imagine. And then it's for the immunology-related study, but they'll accept other NIH-IC funded data as well. And NIDDK has a central repository, NICHD has a dash, NCI has a CRDC. So look into those if you research is funded by this type of NIH-ICs. So now let's talk about resources for finding a repository. So where do I go to find this domain-specific repository? So first, I encourage you to check out the NIH-supported data repositories. So we are focusing more on NIH, but they had the biggest funder. And then with the new NIH DMS policy in place, a lot of researchers are looking for specific repository supported by NIH. So if you go to NIH sharing site, they have a huge list of data repositories, and they have a filter for IC or keyword. I'll show you a screenshot in the next slide, so don't worry about that. If you click on it, it'll take you there. And BMIC also has a nice list of data sharing repository, and they actually revamped their website. So they have a domain-specific repositories and then generalist repository. And domain-specific repositories have 5 filtering options. I will show you next. And then generalist repository has this list of repository. You can click on it and go to there. Now I'm going to talk about these two NNLM data repository finder and then NICHD data repository finder. This one has a very nice like a tile style graphics interface. So it's and then you can compare selected repositories. So it's kind of nice one if you can find it. It has a limited number of repositories, but if you can find one, it's a really good place to find those repositories. And then if you are looking for repository to share genomic data, NIH has a very nice list of repository for human genomic data and the non-human genomic data. And NIH also supports a great repository, generalist repository ecosystem initiatives. So the first slide is NIH sharing site. If you go to this website here, it looks like that. And then if you click on here, it will show all the NIH ICO, and you can just click one of them. It'll kind of show only the repository supported by those ICOs. But a lot of them actually allow other ICs to deposit it there. So don't get discouraged. And then you can type in keywords like imaging data or genomic data, and they kind of rearrange those kind of things as well. And there's a link to that repository and then how to submit, which is kind of nice. And then also has a filter for open data submission. So another nice place to find a repository is a BMIC, and this is what it looks like. And then there are 2 tabs, one for domain-specific repositories, the other one for generalist repositories, and has a more filter, ICOs, subject area, model system, access type, and properties kind of stuff. And this is what many people might find it useful. And this one is based on the BMIC data repository database. I was involved in this project. It was developed by NYU Langone Health Science Library, led by Nicole Contexis, and then with a lot of MLA Data Caucus librarians. And then it uses a Finder module developed by Cornell University. So it has a very nice graphical interface. So the filter is on the left side. And if you select one of them, for example, if you, select, NIA, and it is, select repositories supported by that. And then you can select a couple of them. You can select as many as you want. And then it gives you a comparison table like that. So it's kind of nice way to kind of see which one you want to deposit and stuff like that. The NICHC is similar, and this one was developed by MIT Lincoln Laboratory with the support from NICHD. And this one thing I like about this one is it has like a 5 major filters here, but then there's additional 6 filters, and this one shows up very nicely here as a snapshot. So you can have a quick information about whether offers control access, the persistent ID. I love that part about this repository finder. You can quickly find which PID they use. So if you want to go into detail, and then you can view the details, but important information, you find it up front. So this is really nice. So and then whether they collect the metadata or not. Unfortunately, if you click on imaging, actually the only thing that pops up is EMDB, and the rest is a general list of repositories. So they need to increase the number of repositories they can pull from. And other than that, the interface itself is really great. And that if you select, you can compare up to 3, and you click on compare, and it gives you this nice comparison table, which is really nice. So this is a genomic data repositories. Sorry, I have a little error there, but that's not IDR. So this one gives you a list of human genomic data, and this one gives you a nice list of non-human genomic data. And they also have a link to genomic data sharing expectation by NIH Institute and Center. So each IC has their own kind of expectations, so make sure you check them. And if you click on here, actually, you can kind of enter some keyword, and they have a recommended list of genomic data repositories. So encourage to use that one as well. So now let's talk about the biggest, largest database on earth for data repositories called the re3data.org. So Registry of Research Data Repositories. I have to warn you though, so not all repositories listed here meets the desirable characteristics of data repositories recommended by NSTC. So you have to be aware of that, because some of them might just register and then they don't always offer keys and stuff like that. But it is a very useful database to search, it's the first place to kind of search something. So you can browse by category, but you can simply search. Searching function really works well. But if you go to the top navigation menu, and then if you click on browse by subset, it gives you a really nice colorful wheel here. If you click on one of them, it'll kind of show the list of repository and then show the filter. And see, they have a very extensive list of filters you can choose. If you click on browse by content type, and then it gives you this list. Again, if you click on one of those, it gives you a list of repository on the right, and then list of filters on the left. So, if you want to just kind of narrow down, go here first, and then check that. And if you're looking for specific funder supported repository, go to your funder site. So I'm going to talk about Gray repository. So this one is kind of funded by NIH ODSS, a generalist repository ecosystem initiative. So if you don't find any domain-specific repositories, you can look into Gray repositories. If you click on here, it gives you a nice comparison chart of all these Gray repositories. The Harvard Dataverse, Dryad, Figshare, Mendeley Data, OSF, and Vivly. And then has a description, file size limit, total storage limit, what kind of a PID they use. They all use DOI, or some use a handle, and then other stuff. And recently, So they're very organized because it's funded by ODSS. So they meet regularly, monthly, and then they try to kind of harmonize their activities. The most recent one is that they actually came up with the metadata recommendations. So they have a minimum standard across all this great repository, which is really nice. So it's based on the data site metadata schema 4.4. And then all of them will have standardized metadata schema, so which we're kind of leveling the field for all these different repositories. So let's talk about institutional data repositories. So I attended the LDAP last week, and there was a very interesting report saying that the number of data sets shared in IDRs increased by 157% between 2020 and 2023. So if you click on this link, you can see the poster. But this growth rate is anticipated to increase even further as the NIH DMS policy goes into a compliance phase. If you are reviewing a lot of DMSPs, you will see many people put their institution repository as a kind of catch-all repository. They can find data type, or that, kind of pressure time. They don't have time to look for it, but they can change it later once the grants gets funded. But so it's becoming more and more important. If your institution has an institution repository, many researchers select that because it's no cost, and then they get personal attention. We offer in-person meetings or Zoom meetings, so they feel very comfortable. A lot of others are automated, and if they want to talk to somebody, it's hard to do. And it's a generalist repository, so it can accept any kind of data. Common limitations RDRs have, as many institutional repositories do not offer restricted access to sensitive data. So many of them have just open access. So for example, WashU has 2 repositories, but one offers just open access, but we do offer restricted access. So if you are lucky to have both options, that's great, but many of them have just one. And oftentimes storage costs money, so they don't have enough storage space for big data. There's another one. So, and then insufficient resources, for example, we have 2 people in our team. We're doing pretty much everything, including, DMS reviews and consultation and data curation. So if the demand goes, high for data deposition, we are short-staffed, so that's another issue. So insufficient resources when demand goes high, and then it might not meet all desirable characteristics of data repository for federally funded research. So there's needs to be some quality assurance in place if more IDRs will play a big role in complying the NIH DMS policy. So I do see the community effort, especially led by Data Curation Network, with the support from NIH ODSS. So they are checking the institutional repository readiness. So if you click on that, so they have a project ongoing. So they check, how ready they are in institutional repository. And then they're actually organizing the summit I'm really excited about. The date has not been announced, but sometime in August. So they're going to have this summit to discuss institutional readiness and check the current status, and hopefully we'll get some maybe funding, and NIH will kind of incorporate it into part of the DMS budget, for example, something like that. So are you ready to share? So if you're ready to share, I want you to think of sharing in terms of what the others will want to see. Take a step back from your own data and view it as an outsider, and then share your data with others as you would like data shared with you. So a lot of times when I create the data, I get a lot of pushback from researchers. Oh, I need this information for your metadata. I say, why do I need that and stuff like that? Because others don't know much about your data. So the more you share, the better they'll understand and they get reused. So it's a constant toggle back and forth, but just to put yourself into other users, seat and see what information they want to see, when you share your data. So with that, I think that's the end of my talk, and we'll open for Q&A.
Thank you so much. That is if both you and Nina shared just a wealth of information. And Nina, I appreciate you keeping up with the chat. Feel free to add your questions to the chat before we transition to the open Q&A. I'm going to give a brief highlight to shift over to my colleague, Stephanie Hagstrom, who will talk about our help desk resource as part of DataWorks. Get to that slide. And it likes to go forward. So some of the resources, if you are new to the Salon series, we have a lot of data management guidance. We build on the wealth of our speakers for the Salon series. We have a whole YouTube channel devoted to the recordings, including snippets of our Salon recordings, as well as the full length recordings. Stephanie will talk to you about our help desk resource, but this is a knowledge base that's meant to help you answer questions. If you don't have access to a Sun Young or a Nina right at your fingertips, you have that opportunity. We also have a newsletter for DataWorks activities going across the spectrum of activities, so you can keep up with what we're doing. So with that, I will turn it over to my colleague Stephanie to walk you through the help desk.
Great, thanks so much, Yvette. I'm going to share my screen, I hope. Make sure.
I'll stop the share on my side.
Okay. Yeah, thank you so much. I'm the program manager at FASEB DataWorks initiative, and I've been working on the help desk. And right here, you're at the FASEB.org, but I wanted to show you how to get to the help desk first. And then I'll do a quick run through because I know we're a little over time here. So in January, we relaunched the DataWorks help desk as an interactive knowledge base. And there's a self-search function and also a support bot. And when you go to the FASEB.org, if you click on menu, then you go to data management sharing. Can you see my slide, everybody?
Yeah.
Okay, good. Then you go to DataWorks help desk. This will bring you to our new landing page. And on the landing page, you can click here for the knowledge base. There's also a chat bot, and then there's blogs and salons and some information and some more information about the whole DataWorks program. So you can get to all of the programs from here. But we're going to look at the knowledge base today. So this knowledge base is designed as simple how-to guides. We actually interviewed a whole bunch of researchers, and they said, just tell me what I need to do. So that's what we did. So this knowledge base was launched in January, and it's got how-to guides on all the different data management things. In fact, when I was walking through, listening to the talk today, we have guides on PIDs, we have guides on the DMSP, NIH elements, we have README files, we have qualitative data guides. So a lot of what Nina and Song, sorry, I always say your name wrong. Anyway, I apologize for that, spoke about today. Okay, so you can ask a question and the system will bring up a list of guides, or you can go to any one of these categories to find the how-to guides. Now, our how-to guides have, what is it? Every single guide has, what is it? What is what is a repository? Why do I have to look for a repository? What do I need to know? How to use it? Step-by-step guide. And then there'll be a whole section of tips, examples, additional resources, and related articles. And I'll go really fast through some of these. So if you look here, you'll see, let me make it a little bit bigger. This is all the categories. So if you look at choose a repository, it says, what is it? Why do I need to do it? The different types. Specialist data repository. So a lot of what was spoken about at the previously, workflow, choices, and I'm going to add the Salon link to this into this guide so that you'll be able to have access to that. Finding repositories, and then key characteristics when considering selecting a repository, and then additional considerations for human data. There's a video, every guide has additional resources and related articles. and the sources of information. So that's every single guide is similar to this kind of layout. And the number one guide so far that everybody's been looking at is finding a repository. So that seems to be something that a lot of people are needing. The second most popular guide is budgeting. And budgeting in this particular case is a lot about NIH because DataWorks members are biosciences. So we have information about how to budget for a data management sharing plan. We have writing a data management sharing plan. And all these are separate guides. For element 1 was mentioned today, element 5 was mentioned today. And this is from the data management online DMP tool from CDL, and Nina is on a committee that helped us write this. So this is almost verbatim from the DMP tool. And it has examples of what you should put, what you can put. There's a whole guides on persistent identifiers. And I will go ahead and add the 2 that weren't in there, RAIDs and DMP IDs, but we have ORCID, step-by-step guide, RRIDs, DOIs, RORs, managing your research data, choosing stable file formats, efficient data management structuring, data discovery, and so on. So these are, like how to publish. There is information on README files, data documentation and metadata, how to create README files. So it's extensive. We've got over 40 guides at this point, and we're adding to them weekly. I wish I had a little more time, but I do want to give some time to questions, Q&A to the speakers that were before me. But please do check out our help desk. And each one at the bottom has a little comment where you can let us know if you thought it was a good article or not. That would be helpful as well, because this, as I said, is fairly new. And then we're just now adding blogs. And one of the things we're going to be doing is helping the community. So if you have something that you'd like us to lift up and tweet X out, not tweet, but X or LinkedIn, go ahead and you can send that to me. And I'd be happy to set up a blog for the community. Okay, I felt like I just went right through everything. So I think that's it for me. So I can give like 4 minutes left for questions. You bet.
Great. No, and I know Nina was answering some in the chat, and I just want to point out we had a nice little comment about the knowledge base looking great. I shared that link in the chat as well. I want to give the opportunity for participants if you want to go ahead and unmute and ask any questions of our panelists. I know for me, sitting in on all these salons, I love how, even though this was about selecting a repository, you touched on some other pain points that come up for researchers. So Nina, you hit one of my favorites, naming files, and Sun Young, you talked about like depositing or preparing your data. It's expensive. So what other things are just those common pitfalls as you're getting ready to select a repository? Should researchers be thinking, I mean, you did the nuts and bolts, but like what's the one thing for each of you that a researcher comes and makes you crazy that they haven't thought about this as they're getting ready to, and we'll conceal names, we'll protect it. But the biggest mistake that you see as you're helping researchers prepare their data for deposition?
Since we're thinking repositories specifically, I think mine is going to be, if you know that you're going to use a data repository that has specific structures for the data and especially the documentation to go with it. I'm thinking about dbGaP. This might be on my mind because we're chatting some about genomics, but also the NIMH data archives and some of the NCI ones too. They want the documentation to be very specific, and it's got to be in a certain format that after the first time one has run into the difficulty of harmonizing with a repository, probably from then on, that documentation should be collected in a way that will move the whole lab into depositing it the way that the repo is going to want. Because if it always has to wait till the end, then the deposit process is always going to be painful. So try to keep that harmonization process, that how the variables need to be structured, in mind in advance.
Planning for your data sharing before you collect the data, right?
Oh yeah, plan early. It can't be too early. So as I review so many DMS reviews, NIH wants to know the submission and release timeline often. So release is when you actually publish the DOI, for example. But submission is when you submit your data to a specific repository. There's a curation process. So depending on their backlog, it could take a couple of months. So you have to make sure you give yourself enough time to, provide all the metadata they're looking for and all the supporting documents they're looking for. Otherwise, you can't publish on time. So don't wait until the last minute and try to scramble. So plan ahead. And the constant struggle for me when people come to our institutional repository is filling out the README file. So that's why I said, we have the Connect version has a very detailed information. And then some repository will have a special metadata field, step to reproduce your results. So you can summarize your method to collect the data or analyze the data there, but README file template will have that information. So if you really want to do it right, have that in your data folder from the beginning and collect all your contributors, ORCID ID ahead of time, grant ID, fund.raw information. If you have any questions, reach out to your, data librarian. They'll provide information for you. If you have that all ready, and then update as you go if things change, but then you don't have to scramble at the end. And remember, your DMSP is a living document. It's not set in stone. If you need to change the repository, you're allowed to change it, but with a caveat, you have to get approved. Until then, your previously approved DMSP is in effect, and they have a specific requirement, at least 30 days prior to the effective date. So if you're gonna, deposit your data in a different repository than what you said you would, then make sure you send the revised DMSP, get reapproval before you submit the data and get published. Otherwise, you get in trouble. So that's the advice I would give.
That is, we both gave great advice. I definitely was clapping at multiple points. And the living document piece is very important to keep up with everything. I know we are at the top of the hour, and I just want to go back to just for those of you who want to join us next month. And of course, I can't find my share button. It's like green. Next month, we'll continue building on some of the topics from today, April 17th, 1:00 p.m. Eastern, best practices for data in journals and publications. So we'll keep an eye out for that information about that, Salon. We know that came up even today about thinking about what you need for your publication. So if you also want to learn more, you can join us, check out our DataWorks resources. You heard about the help desk, sign up for our newsletter. And I thank you so much. Thank you, Nina and Sun Young, for sharing the wealth of information. We are so fortunate to have you